For our last week of Radar School, we're going to talk to you about one of the newer products provided by radars thanks to an upgrade that the radars got about 15 years ago called dual polarization. Now, dual polarization gave us a lot more information, and all it is that original pulse that comes out from the radar that's actually a wave that has always been going in the horizontal. The main reason they put out a horizontal wave is because rain falls through the atmosphere, but now with dual polarization, it sends out two waves. It sends out the horizontal wave, and it also sends out a vertical wave out from the radars. And what that extra wave does, it gives us more information on the size and shape of objects that it's hitting. So namely, if it's hitting rain, is it hitting hail, is it hitting some dust or debris that's in the air? That's what dual polarization has done for us, and it gave us one of these products called correlation coefficient. Now, this is the last product that you see us use often on TV. It's a lot of times what we put up and we call it debris tracker or just debris, and that's where we're looking for any type of debris being lofted in the air by a possible tornado on the ground. It's really the only way to confirm a tornado on the ground without spotters seeing it. It's the only way to confirm it via radar. So it's a measure of how similar objects, though, are to those around them. What that means is that when that beam goes out, if it's only seeing rain, it's going to say, yeah, all these objects are pretty similar. If it's seeing some hail mixed in, it's going to look a little bit less similar than just rain on its own. And if it's seeing a bunch of dust, wood, whatever being lofted in the air by debris from a tornado, it's going to say none of these objects are very similar at all. And that helps us identify exactly what's going on with thunderstorms as you look through them. So it's useful for detecting debris and generally large hail. And it's also useful in the winter because it helps us identify winter precipitation type. Is it freezing rain? Is it sleet? Is this snow? Another area where correlation coefficient helps. But a lot of times we're talking about it here with severe weather. And that high CC, once again, whenever we're seeing a pretty good correlation, all this area in red, that's going to be generally rain. As you see the moderate CC, and that's going to be some of these areas now we're now seeing in the green colors. That's a lot of times mixed precipitation, or with severe weather, we're seeing some more hail in the thunderstorm. And in the low CC, saying these objects aren't similar at all, that's generally when we start to see debris or other objects. We can see this on radar on a plain day if there's a ton of birds flying around, or some of the areas where you see a ton of insects come out at night. You can see a lot of times that pop up there, or our wind farms. We can see the wind farms here locally with the correlation coefficient. We can identify it as not rain, but something that's non-meteorological. So looking at the debris detection now, one of the important things here is to always identify the area of rotation with the possible debris being lofted in the air. I'll point out this area right here. See how there's very little correlation, those areas in the blue on the backside of the thunderstorm. There's also not any rain right there. It's not going to have a lot of correlation because it's kind of between cells there. But you look further down to the south there, you see this little debris signature, that little hook echo in the thunderstorm, and there's our little bit of a debris, or what we call a correlation coefficient drop, and that's where it's going to be a very low CC. That's how we can identify the radar, and you zoom in a little bit, here's our velocity signature, and right there, there's our debris signature. And also point out some higher areas of reflectivity in there that we've talked about that could be identifying as hail. It also correlates with this area in the green with moderate CC, generally confirming that, yeah, that's going to be hail that's occurring in that part of the thunderstorm. And another example of this is actually going to be, this previous one was actually the tornado that went through Lockett a few years back. And then this other one is actually one of the tornadoes that was in Jackson County this last year. And similar story, you get this main little hook echo, and you can identify down here, there's our debris drop. There's a large debris signature right there. Same thing with the velocity signature here, very powerful velocity signature, also lining up with our drop and correlation coefficient. Now, this is one of the newer products, like I said, that's been added in the last 15 years thanks to dual polarization of the radars. And it's also the last product that we're going to talk about in this segment, because it's really the main three that we show on television. I hope you have enjoyed these segments over the last few weeks. I hope you've learned a few things. Thanks for watching Radar School.